Good morning, students of grade 9. Today we are going to solve some exercise about mechanical action and equilibrium. In the first exercise, a solid body S of mass 500 grams rests on the surface of a horizontal table as shown in the adjacent figure, given that the gravitational acceleration g is equal to 10 Newton per kilogram. The first part. List and classify the forces acting on the solid body. When we want to list and classify, we must write the name of the force, its symbol, and then classify it into contact or acting from a distance force. The forces acting on S are the weight force, its symbol W vector, and its acting from a distance force, and the normal reaction of support, its symbol is N capital letter vector, and its contact force. Part 2. Find the magnitude of the weight of S. To find the magnitude of the weight of S, we use the formula weight is equal to mass times the gravity. We must be noted that the mass must be converted from gram into kilogram, its SI unit. So, to convert from gram to kilogram, we divide the mass by 1000, so the mass becomes 0.5 kilogram. Then, by substituting the mass 0.5 times the gravity 10, which is given, the weight is equal to 5 Newton, its SI unit. 3. Give the characteristics of the forces acting on S. To find the characteristics of any force, we prefer to make a simple table containing the two forces we have and the four characteristics for any force. Let's start with the characteristics of the weight force. The point of application of the weight force is always the center of gravity of the box or the body we are studying, which is this point in here. The line of action of the weight is always vertical. Its direction is always vertically downward. We must always write vertically downward, not only downward. Its magnitude is calculated in part 2, which is equal to 5 Newton. Now the characteristics of the normal force. The point of application. The point of application of the normal force is the center of contact between the box and the table. This is the contact between the box and the table. The normal force is applied on the center of contact, which is this point in here. This is the center of contact between the box and the table. So this is the point of application of the normal force. The line of action of the normal force is vertical and its direction is vertically upward. The magnitude of the normal force is 5 Newton. Now we are going to talk how to calculate the magnitude of the normal force. Before we calculate the magnitude of the normal force, we must be noted that when I tell you in the given that the box rests on the surface of a horizontal table, this means that this body is at equilibrium. When this body is at equilibrium, we can write the condition of equilibrium applied by two forces, which is the weight vector plus the normal vector is equal to 0 vector. Which means that the weight vector is equal to minus normal vector. As a magnitude, the weight force is equal to the normal force is equal to 5 Newton. Now represent these forces on S according to the scale 1 cm 2.5 Newton. To use this scale, we write the scale in here 1 cm 2.5 Newton. Each 1 cm drawn represents 2.5 Newton as a magnitude. The both forces we have are 5 Newton, which means that we put the 5 Newton below the 2.5 Newton, and X is the length of the two forces you are going to draw. To calculate X is equal to 5 times 1 divided by 2.5, which is 2 cm. So we draw the weight and the normal force 2 cm. We draw the weight force from the center of gravity of the box vertically downward, and we draw the normal force from the center of contact between the box and the table vertically upward.